we are getting the knowledge about your data. Yeah, that one. Yeah, that course module. Yeah, someone asked. Yeah. So maybe some of you already completed, right? No worries. Maybe you completed. Maybe just revise the things and you can submit the certificate, right? Just to get some idea about the things, right? Even that is not enough, right? Just I'm giving you some basics. So if you need more, there are some other course modules in Coursera, right? So you can follow. That is a fully the machine learning part also included. Then also you need the mathematical things, right? Then only you can complete that course module, right? So it's up to your requirements or your need, right? So if you have a knowledge, you can easily get complete your research, right? Maybe yesterday and day before, we have interim presentation, right, for the final year students, right? So maybe if you notice or if you participate that sessions, you can understand. Uh, some of you they don't have knowledge, right? Just they are copying code from internet, right? They will do something, right? That is not research, right? So if you are planning to do a research or if you complete your research, definitely you need a vast knowledge on that area, right? That is the uh, successful completion of a research, right? So definitely you have questions while you apply for an interview for a company. Definitely you have some questions based on your final year research project, right? So what are the challenges you are facing? How you are sorted out these problems? There are so many questions, right? So definitely they will ask, tell me about your final year research, right? So depending on the way how you answer the questions, they will understand whether you are doing the research or not, right? No need to evaluate from the beginning to the end of maybe the panel. The way how you are answered, they will understand whether you actually actively participate on that research or not, right? So that's why I'm telling you, right? Maybe if you're planning to do a research related to this area, data mining or data science or machine learning, definitely you need to get a vast knowledge on the basics, right? How we are dealing with missing values, what is the internal mechanism to fill the missing values, right? The thing here, the clean the data set, right? So if it is a image data set, how we can apply the computer vision or image processing techniques to outlier removals or the noise removals. There are so many things, right? I don't think you have a subject called mm, a subject called yeah, image processing, right? I don't know. I don't think so. Right. If anyone planning to do this area, just learn these topic, right? Image processing or and computer vision, right? If you have this knowledge together with machine learning, you can go at depth, very depth level, right? So you have so many research ideas with this knowledge plus machine learning, right? So if anyone interesting, just you can spend some time, right? This is the time you need to prepare for your research, right? Don't think maybe for fourth year, final year, we are working on our research, right? So this year, the third year, you need actively participate to prepare for your research, right? So it means now you can think which area I'm planning to do the research, right? Once you plan the research area, then you can get the knowledge, right? From here onwards, little, just learn and get some knowledge, right? Maybe you have some subject called literature review, right? So it means if you have a domain to do a research, first of all you need to find out what are the things already they done on that topic, right? So then we can call that it means literature review, right? The we will give me a minute. Hello. Yeah. So here from this semester onwards, just learn the basics, right? So whatever your area, just learn little bit little. You can read some papers, research articles, and you can get some. idea. You no need to read the entire paper. Maybe you can read some abstracts and introduction, right? So depending on that, you can get some, you find out your domain, right? Your topics, right? That is mandatory to become a successful on your research. Maybe if you attend yesterday, you can realize that some of the students, they don't know anything about, right? The very basic questions, they don't know how to answer, right? So it's not a healthy for your career, right? If you don't know anything, maybe even if you have A results, that is a useless, right? Without the knowledge, the paper qualification, no one can accept, right, by the industry. So just think about those things, right? Mm, yeah. Okay, now we will move for the topic, right? So, so today we are going to discuss that get to know your data, right? So now tell me why you need to get to know your data. What is the reason? Tell me why you need to get to know your data. So it means you need to get a clear understanding about your data, right? So what is the importance of that? Why it is mandate as an initial state to do a data mining task or data analytic work? It is mandate. This is the first step you need to do, right? Sorry. Tell me some importance. So, or tell me if you don't do the, if you don't have a knowledge about your data, so what will happen? Without the proper knowledge of your data, if you are doing something, what will happen? Tell me, what are the disadvantages or
But sir,
just think, yeah, tell me.
so what is the question, sir?
Yeah, I'm asking you, right? Before you do a data mining task, right? First of all, you need to understand your data. So what is the importance of that one? Understanding, data understanding. What will happen if you don't have enough knowledge about your data? Just you apply something, some data mining techniques, and if you find out something, what will happen?
If we don't know the concept, we can't move on with the project, right?
Yeah,
And it will ended up failure.
yeah, maybe you are not getting the expected outcome from the projects, right?
Yeah, sir.
Yeah, we are not getting proper decisions, right? So the important thing here, right? If you are doing a data mining task, right? First of all, you need to understand your data, right? To do this type of data mining, right? Let's say if you are introduce a promotion for your customers, right? So you need to think for whom, for which customers we are planning to give the uh, promotion, whether postpaid or prepaid customers. Just imagine if it's an internet service provider, if they are planning to give uh, some promotional packages to their customers, right? First of all, they need to think to whom, who are the customers. So we are planning to give the promotions, right? For uh, prepaid or postpaid customers, right? So then what will happen? The data understanding means, so you need to find out if you have a prepaid customers, they have different attributes, right? Different behavior or different characters, different features, right? Similarly, if it is a prepaid customers, they have different set of attributes or features. Maybe they both have some common features, right? Even if it is a postpaid customers, you need to think about their regular bill settlements, right? Is there any disconnections due to their they are not settled the bill proper time? You need to be I find out some that behavior as well, right? How they are, how the loyalty of the customers, right? In their payments gateway. You need to think so many things, right? But not the case in prepaid, right? So just think about if you are doing the same attribute, right? Same data for both researchers, right? Let's say in your manager says we need to do something. We need to introduce some. Sorry, we need to introduce some promotions for prepaid customers as well as postpaid customers, right? This is the uh, task your manager says, right? He assigned a person A for prepaid customer, a person B for postpaid customer, right? So two data scientists are assigned for this topic. You need to do a data analytic and you need to find out some outputs, or you need to do some recommendation, right? Based on the past data set, which type of promotion. So we can provide what are the promotions we introduce benefit for us and the customers. Likewise, they are asking some question, right? So to answer this question, right? So first of all, you need to understand, right? If it is a prepaid customer, you need to think about which attributes you are consider for these findings or for this classification or for this clustering, right? But if you think about the postpaid customers, he will consider some attributes, right? Some columns, some attributes he will consider for this task, right? So if what will happen if both tasks use the same, right? We cannot say we can guarantee that we are getting the expected outcomes, right? So depending on the task, first of all, you need to understand what are the attributes they are impact your predictions, right? So if it is a postpaid customers, definitely you need to find out the attributes. That attribute means the different columns, right? The different attributes, they are impact your results or they are influence the outcome of the data analytic task, right? So for that one, definitely you need to know about your data, right? If you know the proper knowledge about your data, then only you can further proceed with your predictions or outcomes, right? So end of the session, you can understand data objects, right? There are two things, right? Data objects and data types, right? Data types, I think you're already familiar, right? Data types means that is attributes, right? The different types of attributes. Attribute we already know, right? The variable in programming language, we can say the variables, right? You're creating some variable for whole, some values, likewise, right? So attribute means, let's say, uh, maybe you are learn those things in your database, right? DB, right? In the database subject, you can call, let's say, if you have a university database system or university system, on that, sometimes you are asked some question to draw the ER diagrams, right? Entity relationship diagram, right? So here we have entities, right? So each entity have some attributes, right? So you know what is attributes and entities, right? So the data objects means the entity we can call as a data objects, right? Attributes means, so to define this entity, you can use this attribute, right? So let's say if it is a university system, right? Just imagine this entity is a student, right? The entity name is student, right? So if it is a student entity, they have student ID, right? They have their name, right? Maybe their GP, right? Or maybe there are so many things, right? Which year he's studying, right? So attributes means to define that entity or to behavior to find out the characteristics of that attribute. Sorry, to find out the characteristics of that entity, we need attributes, right? By using attributes, we can define the entities, right? So you can understand what is this, right? Similarly, you can understand there are two different types of attributes, right? Discrete data and continuous data. If you think about the data collection or data sets, they have two types of data, right? Discrete data and continuous data. That is one way we can categorize, right? Another way we can categorize the data into nominal, numeric, binary, uh, ordinal, likewise, right? So different types of data we are dealing if you are doing a data mining task, right? So once you do a data mining task, definitely we cannot always use the numeric data. Numeric means number data, right? So sometimes we have some binary data, or sometimes we have nominal data, sometimes we have ordinal data, right? So we can understand what is this nominal, what is this ordinary, these things we can understand throughout this subject, right? Also we can look at how we are visualize the techniques, right? Maybe if you sometimes what will happen, right? If you are doing a data pre-processing, right? You need to visualize something, right? Let's say if you have, let's say if you have some data set, right? Just imagine you have 5 or 4 columns, right? For a data set, right? Here we have 50 records. We have 50 records, right? With 5 attributes, right? Now what you need to do, the distribution of the data, right? So distribution means whether the data set is distributed in proper way or they have some abnormal things, right? So the distributed means likewise, it will in the symmetric way or something. So there are so many things, right? So to find out these proper distribution of your data, you need to plot the data, right? So Plotting is a one technique we can find out for different features from your data set, right? So the plotting means just nothing, just you can draw in a graph, right? Visual representation we can call the plots, right? So you can understand what are the different types of plotting, right? So we are discuss only few types of plottings, right? But there are so many types, right? So depending on the requirements and depending on the topics or depending on the research, you can use different types of plottings, right? So no need to worry about, just we are giving some basics here, right? Okay, yeah, now we will move what is the difference between data objects and attributes types, right? So if you have a data set, right, let's say you are planning to do a research, right, weather forecasting, right, or weather predictions, right? Just imagine you are planning to do a research on weather predictions, right? So the prediction and forecasting, two different things, right? That they are not same. Maybe you can tell uh, in English, maybe we have same meaning. Forecasting and predictions are different things in the data science terminology, right? So the forecasting means that is we can call as a time series analysis, right? You're forecasting, right? Let's say you have last 10-year data by monthly data. Just imagine you have last 10-year records for monthly data set, right? So monthly rainfall data. Just imagine you are find out a particular location, right? Just you are find out the university surrounding, right? You have the data set of rainfall data last 10-year monthly rainfall data, right? So based on that data, you can apply something called time series analysis, right? Arima, if you want, you can learn these things, right? Time series analysis. By using this time series analysis, we can predict what is the rainfall by next month, right? Maybe next 2 months or next 1 year, we can predict the rainfall. Or sorry, maybe we can predict the rainfall by applying these time series analysis. These we can call forecasting, right? Predictions in the sense that is a different idea, right? So if we are doing a predictions, you have a past data set. Here also you have a past data set, right? But here in the time series analysis, like let's say if you are predicting the rainfall of this next month, you are predicting the rainfall of next month, the rainfall of next month, it influenced by the rainfall of this month and last month on before last 2 months ago. Likewise, it will influence by the previous month output, right? But not the case in predictions, right? So predictions means you don't need the sequential data set. You don't need the continuous data to do the predictions, right? Let's say if you have some tuples means maybe you don't have the continuous last 10-year data. Maybe you have some data set with different months with their different rainfalls, right? But you don't have a continuous data. So by using these data, if you do some output, so if you do some predictions, that is, if you do some future values, like let's say based on the humidity, temperature, maybe some the cloudiness, or we are using these parameters, you will find out the rainfall here, right? So it means you have some values for this one, right? Maybe last month you have the temperature 26 and there are some parameters. Depending on that, the rainfall becomes 75 millimeter, right? Here we have different values. Maybe here 85 millimeter, here 15 millimeter, right? So this type of data, they don't have a continuous data, right? So based on this, if you do some predictions, right? Let's say you have a new parameters, new temperature 28, humidity 45, then the other parameter. So now you need to find out what is the what is the rainfall value if you have these parameters. This is we can call predictions, right? So in this type of predictions, what will happen? We are not considering the continuous data, right? Just we have collected data without continuity. By using this data, we are doing some predictions, right? The problem here, if you are doing this type of predictions, right, there are more possibilities to error rates, right? So it means from this data, you can find out, you can plot the graph, right? Let's say. if you plot this type of graph, right? So you can find out the line, right? So it means that line is not goes all throughout all the points, right? So if you have a data point here, this is the error value, right? This is the error values, right? Maybe some points it will without error. Right? This is actually predictions, right? So if it is a forecasting means in the forecasting, right? This is it goes this way, right? It means the continuous variables, right? So if you are doing a prediction by tomorrow, it will impact by the previous records, right? This is the difference between forecasting and predictions, right? If you are doing a forecasting, what you are doing, you need to analyze the continuous series of data, continuity data, right? So definitely your next month predictions impact by the previous month's data you have, right? But not the case in predictions, right? Just understand those differences, right? So maybe even if you do face an interview, or if you are facing a proposal defense or something, definitely sometimes they will ask what is the difference. So if you understand those things clearly, then only you can answer these type of questions, right? Okay, data objects means, let's say you have a table, right? You can easily understand, right? Rather than you don't need to memorize the things, right? Just imagine you have a table, right? Here, student ID, right? Age is there, right? Yeah, number of years experience, working experience, work experience, right? The last salary, last month salary. Likewise, you have some maybe rather than student, right? Just think about this an employee, right? Employee ID, age, years of experience, and their salary. Just imagine we have a data set, the employee data, right? The employee table. We have an employee table. So here, if you think about the data objects means, okay, if you think about the data objects means these values, right? This is we can call data objects, right? We can call this is data objects. We can call these as a data objects, right? So this first row we can call as a attributes, right? So I don't need to explain these more. Right? You're already familiar with attributes, right? Here we are planning to discuss different types of attribute, right? So you know what is attribute. Now here we are going to discuss what are the different types of attributes we have, right? So the data objects means this tuple, right? So if you have a one record, that is a one data objects, right? This is a data objects. This each row we can call as a data object, right? So altogether we can call for the data objects, the collection of data records we can call as a data object, right? So if you have another database, right, the here maybe just suppliers, right? So you have another table suppliers. So on that table also you have some data objects, right? So the first record is an attribute, remaining part is we can call as a data objects, right? So the rows we can call as a data objects, the columns we can call as a attributes, right? So to describe one data objects, definitely you need to use the attribute, right? Let's say here there is an employee ID 10, employee ID 10 is there, right? So this data objects describe the behavior of this data object described by using these attribute values, age attribute value, his number of years experience and attribute value, right? By using these attribute values, we can define the data objects, right? So you don't need to worry about, right? I think you know what is data objects and attributes, right? Now, the important thing here, we need to remember what are the different types of attributes we have, right? That is what we are, what you need to understand, right? And we have some questions for based on that. Okay, yeah. Attributes means I already told you, right? Each column we are considered as an attribute, right? So the characteristic of a data set we can represent with the help of attributes, right? So the same attribute we are called by different names in different subjects, right? So if you have a, I don't think so, you have a subject called data warehousing, right? So in data warehousing, we can call attribute as a dimensions, right? So in data warehouse, we have something called data cubes, right? So you don't need for this, I think we have some basic introduction about data warehouse here, right? I don't know for here or that fourth year subject. Maybe that's considering fourth year subject. Data warehousing it's related to business domain. So normally it comes in for data analytics subject. I don't know here that data mining is not coming here, right? But if you want, I will explain, right? So the in data warehousing we define some data cubes, right? So data cube means this is one attribute, right? Just think about this is a time. This is cells, how many number of item cells, right? Maybe here, this one is a branch, different branches, right? Or different branches. So within each cell, right, you have some values, right? So the time means the month, January to April, May to August, sorry, January to March, April to June, July to September, October to December. Likewise, this is the duration, right? This dimension for duration, monthly duration. These are the branches: branch A, branch B, Ampara branch or Kalmuna or Livil branch. Likewise, we have different branches. Here, number of products we are selling. Likewise, this is we can call data cube, right? So here, the attribute means this one, right? This is an attribute, right? So we can call this is a one dimension, right? In data warehousing, we can call this one as a dimensions, right? Similarly, in machine learning, attribute we can call features, right? So if you are doing machine learning, if you are learning machine learning, they are not using mostly in the term attribute, right? They are using the term feature engineering, right? Feature extraction. Likewise, the term we are using for feature extraction, right? If you are doing a machine learning task with the image data set, convolutional neural network, we don't need to extract the feature themselves. They will extract that the model extract the features themselves, right? So likewise we can call feature. Even if you have some experience with statistics, right? You have a subject called statistics, so there you can use the attribute as a variable, right? Yeah, if you are using the name variable, that indicate the same, right? So depending on the subject, the terms are different, but all are indicating the same thing, right? Just remember these, right? Okay, now we will move for the different types of attributes, right? So attribute types, what are the different types of attribute, right? So one way we can categorize the attribute into this way. In first way, we can categorize all the attribute between these four, right? Maybe nominal attributes or binary attributes or ordinal attributes or numeric attribute. One way we can categorize the attribute into this way. Another way we can categorize the attribute into discrete and continuous attribute. Discrete attribute and continuous attribute. These are the two different ways we can categorize the attributes, right? So now we will look at what do you mean by nominal attribute, right? What do you mean by binary attribute? What is mean by ordinal? What do you mean by numeric, right? Maybe some terms based on the meaning. The term you can easily remember, right? Binary means zero. Binary numbers means 0 and 1. So it indicates only two possible values for this one. Binary means only two possible values, right? Here also, if you have an attribute, we can call as a binary attribute. It means for that attribute only two possible values, right? Tell me an example for this one. Binary attributes, only two possible values. Tell me an example attribute. They have only two values. Attribute means in your table, the column name, right? So tell me a column name, right? So binary attribute means for
Gender.
each, yeah, gender,
Gender.
male and female. Yeah. If you have an attribute called gender, they have only two possibilities, right? Male and female, right? So similarly, maybe you have a column called COVID, COVID report, right? So maybe positive or negative, right? Only two values, right? They have positive, they have COVID, or they don't have COVID, negative. Likewise, you have two different values we can call binary attributes, right? So ordinary attributes are different type of attribute. So hereafter, right, if you have any data set, you need to find out whether it's which type of attribute, this one. Why I'm telling these things, right? If you apply the data mining techniques for different types of attribute, we are using different techniques, right? So if you don't know what is the type of the data, then only you can apply depending on the different techniques, right? The best example, just imagine, right? You have the salary attribute, right? Just imagine, I tell those things we will discuss later, right? Just imagine you have a attribute called salary, right? Salary is a numeric values, right? Maybe 55,000 or maybe 45,000, right? 150,000. Likewise, you have a column, right? Some of the values are missing, right? This one is missing. Likewise, you have 100 employee salary details, right? So now we have a problem. If you have a missing values, you need to fill the missing values, right? So maybe next class we will discuss how to fill the missing values in the pre-processing part, right? On that you can learn. We can fill the missing values with the help of mean, right? So mean means the average value. By using the average value, you can fill the missing values, right? So let's say in your 100 records, 100 tuples, only you have two missing values, right? So just imagine you have 100 records, right? 100 employee salary. Within that, two employees, they are not giving their salary, right? Two missing values are there, right? So now what you need to do, you get the sum of all the 98 employee salaries, 98 employee salary, sum of 98 employee salary, then divided by 98, that is the mean, right? So you need to clearly understand what is the mean. Then only you can say sometimes what will happen. I noticed previous benches, right? They are get the sum of all the 98 students. They can divide it by 100. It's wrong, right? So you are getting the sum of all the 98 student salary, sum of all the 98 students employee salary. Then if you divide it by 100, it is totally wrong, right? So definitely just think about these things, right? So be careful, right? These are the simple mistakes you are doing, right? If I ask some questions to do, this is, you already know, right? Average means sum of all the values divided by total number of the frequencies, number of occurrences or frequencies, right? So here, maybe in the question I am mentioning 100 student record, just you are getting the sum of 98 and you are divided by 100, definitely it's a wrong answer, right? So why I am telling here, right? So if you divide it by 98, right? So then you are getting some values, right? So that value you have filled the missing value. So you can apply this filling techniques that if you have a missing value, you can apply this filling techniques only for numeric data, right? Just imagine you have another attribute, right? Called gender. You have another attribute called gender, right? Here they have male, female, male, male, female, female. Likewise, you have some similarly here also 98 or maybe 95 records, right? Five missing values, right? So we can deal with missing values. Definitely you need to fill the missing values. So here we cannot apply the same numeric techniques, right? Why? This is a different type of data, right? Depending on the attribute type, we can apply different techniques to fill the missing values, right? So here we can use the mod value to fill the missing values in a nominal attributes. We can use the mod value. So you know what is mod? Mod value means the highest number of occurrences, which value occurs highest number, that is we can call mod value, right? So for the find out the mod values, you need to find out how many occurrences male comes, how many occurrences female comes, right? Depending on that, you can fill. Let's say if you have a male occurrences are 45, female occurrences are 50, right? So the maximum highest number of occurrences are female, right? So you need to fill the missing values with female, right? So that is different way filling the missing values, right? Depending on the attribute type, we can use different ways to fill the missing values. So to do those type of things, definitely you need to know what is this type of data attribute type. If you know the attribute type, then only you can do these things, right? That's why we are discussing these, right? So now we will look at what are the different types of attribute. So it means what? That is important. So nominal means you need to understand. If you need to know what is nominal attribute, then only you can find out whether it's a nominal or ordinal, right? So you can understand what do you mean by nominal type, right? So the nominal type in the sense, there is no meaningful order, right? You need to remember if it's a nominal attribute, right? Within the attribute values, there is no meaningful order. Okay. Yeah. Yeah. Just look at here. So the nominal attribute in the sense, right? Okay. Attribute means it's a column, right? So attribute means there is a column is there. For the column, let's say we have 50 records, right? We have 50 records. It means 50 tuples are there, right? For each tuples, we have some values, right? So the nominal attribute means the attributes values have some categories, some kinds of categories or state, right? They don't have meaningful order, right? The nominal attribute means, okay, yeah. Yeah, just imagine the marital status, right? Okay. Marital status is my attribute, right? Marital status is my attribute. Just imagine marital status is my attribute. Let's say I am getting the records for 50 employees in my company for their marital states to find out some insurance, family insurance policies, or we introduce something or some promotions. For that purposes, we need these records, right? So marital status. So at that time, right? So here, what are the different values? Married or single or divorced or with widow, right? These are the four possible values are coming for all the 50 records, right? So here, if it is a nominal attribute means here there are some category, some types of categories, right? Here in this attribute, in this nominal, marital status is a nominal attribute. Here, what are the possible values? Married, single, divorced, or widow, right? So these are the four different types of values are filled for all the 50 records, right? In the 50 records, they are filled with the help of these four values, right? So that is all the suitable values for these nominal attribute. Now what will happen? They don't have any meaningful order. Meaningful order means single is good or married is bad or whatever. There is no meaningful order, right? Order means it is a worst, it is a best. Likewise, there we can say nothing between the values of this attribute. So that type of attribute we can call that is a nominal attribute. Just imagine the hair color, brown or black or gray, white, right? We can say, right, black is a good color, white is bad. Likewise, we can, there is no any meaningful order between the values. Then these type of attributes we can call nominal attributes, right? So if you have a attribute, nominal attribute, so to let's say we cannot apply for nominal attributes the mathematical operations like mean medians, right? So mean, there is no mean value, there is no median value, right? Only we have the mod values, right? So if you are dealing with these marital status, likewise the nominal attributes, always we are dealing with the mod operations, right? The mod means highest number of occurrences of that value, that is we can call mod value. So we are doing most of the time with the mod values. We cannot find out the means or median for the nominal attribute, right? Okay, tell me some example attribute you consider as a nominal attribute. Okay, uh, just think about your grade, right? Your exam grade. What do you think? Your exam grade, right?
It has
Maybe
an
your
order,
exam
right?
grade. What about others? You have A plus, A minus, B plus. What about this one? Is it a ordinal? Is it a nominal? Educational level. Okay. Tell me what are the possible values for educational level? Tell me possible
Kind
values
of
for education.
position. Diploma, HND.
O level, A level, right? So we cannot use, right? The educational level, they have some meaningful order, right? So if you have a degree, right, you have certain level, right? If you have a postgraduate degree, so masters, they have different level. You have a diploma, that is a different level. You have a certificate, that is different level. So educational level, we cannot say that is a nominal attribute, right? So we cannot say educational level is a nominal attribute, right? Nominal attributes means there is no meaningful order between the values. Order means we cannot order that attribute in different ways. If you have some values, we don't have any meaningful order. Meaningful order, that is important, right? So what about this one? Your grade, your marks grades. Hmm? Tell me, what about your GPA? Sorry, your grade marks in your final semester results sheet. They have grades, right? So what do you
So
think?
is it a nominal, sir? It won't be nominal, right? Because it has order.
Yeah, yeah. What about others? So just you can practice, right? Is there ordered values, whatever the attribute, right? Maybe you can think whether it becomes a nominal attributes or not, right? So the what is the theory behind the nominal attribute? They don't have any meaningful order, right? There is no any meaningful order, then we can say that is a nominal attribute, right? So if you look at your grades, right? A plus have a highest order, right? You score very well, right? You got the highest marks. That is the order is there, right? Similarly, if you look at that A minus, right, little bit lower grade, C plus, more lower, the poor results. Likewise, you have meaningful order, right? So that is not a nominal attribute, right? Now tell me, what do you mean by? Did you heard about Likert scale? Likert scale. Did you heard about Likert scale?
No, sir.
No, sir.
Okay, just find out, right? Likert scale in the sense, maybe sometimes if you purchase something, right, they will ask you the feedback, right? Or maybe you give a call to a customer care service. They ask you a feedback. You can score from 0 to 10, right? Or maybe your seniors or maybe your previous badges, while they are doing a questionnaire based on a research, right? They are using this Likert scale, right? So the Likert scale in the sense, right? Uh, you have let's say highly agree, right? Likert scale means this one, right? For a question, or you have 5 options, right? Highly agree, right? Agree, uh, right? Then not agree, highly disagree, right? Let's say this way. Likewise, this is we can call Likert scale, right? You can search in the internet what is Likert scale, right? Likert scale in the sense, mostly while you are doing a questionnaire based on the research, you have 5 scales, right? 5 options, yeah. Best, good, average, worst. Likewise, you have 5 different options. Each option have some values, right? Highly satisfied, average, dissatisfied, highly dissatisfied. Normally, if you are doing a statistical research, right, you are using the Likert scale, right? So what do you think about Likert scale? Is there any meaningful order? So Likert scale in the sense
Yeah,
they have meaningful order, right? So if you have a Likert scale, we cannot say that is a nominal attribute, right? So if you are doing a maybe even you also maybe in your final year, right, you are doing a research, right, based on the questionnaire. Let's say you are developing a, let's say someone doing a research on UI UX, right? User interface and user experience, right? If you are doing a research UI UX side, right? Let's say you are developing a yeah, you are developing a template or by using a Figma tool or something, right? You are designing some web pages, they are linked with some other pages. Then you are using Figma, you can create some user interface, right? Now you can provide this interface for the audience. Like let's say you are doing a research for the academic pupil, or you are doing for the different faculties. Maybe you are introducing an application for some purposes for the commerce faculty or maybe arts faculty, right? For the audience, you are giving this application to use. After they are used this application, right? To get the feedback, you ask some questions, right? For that questionnaire, right? They will ask a question, right? How about the login page? You're asking a question. Login page features are easily accessible. How about the accessibility of the login page, right? Then for you are giving five options. Highly, uh, is it easy or whatever the questions you're asking? Five options. Highly agree, maybe highly satisfied, right? Satisfied, average, dissatisfied, highly dissatisfied, right? So based on that particular person, his point of view, he will give an answer, right? So depending on this Likert scale, you are giving, if it is highly satisfied, you give some marks, right? It is a 10 marks, right? Satisfied means you are giving 7. Average, you are giving 5. Dissatisfied means 3. Highly dissatisfied means 0 marks. Likewise, you have some scales in the background, right? You are not mentioning the background scales, but you are using this Likert scale, right? So the Likert scale is not a nominal attribute, right? So the you need to remember, if it is a nominal attribute, they don't have any meaningful order between the possible values for that attribute, right? So the attribute values are don't have any meaningful order, then we can call that attribute as a nominal attribute, right? So the next thing, binary attribute, right? So the binary attribute means the term says it is binary. Binary means binary numbers are, there are two possibilities, 0 and 1. These are the two values it will come for the binary attribute, right? So the binary number. So binary attribute means if you have an attribute, we can call that attribute as a binary attribute. It means for the all the records, there are only two possible values, maybe whether it's a 0 or 1, maybe yes or no. Only two possible values for that particular attribute, positive or negative. So depending on that, we can say that is a binary attribute, right? So binary attribute also a nominal attribute, right? Just think about binary attribute also a nominal attribute, but they have only two categories or two states, 0 or 1, maybe 0 state or 1 state, right? Or positive or negative state, right? There is no more than two. If you have any attribute, they have all the possible values for that attributes, only two values, then you can say that is an binary attribute, right? So if you are doing a COVID test, right? Only two values, right? Positive or negative, right? These are the true values, right? Or sometimes true or false, right? That's the only two values, right? So if you have two attribute values for an attribute, then we can call that is a binary attribute, right? So if it is a binary attribute, means they have only two values. They are symmetric or asymmetric, right? So symmetric means they are the weights are equal weights, right? If you think about gender, they have male and female, right? So that is a binary attribute, right? So symmetric means they have equally weighted, right? So the equal opportunities for these two genders, right? Asymmetric means asymmetric in the sense some genetic diseases, right? Let's say if you have the severity of let's say asymmetric means they are not equal weighted, right? So one disease is highly negative impact for the human. Another condition, another state is uh, low impact for the human. So symmetric means equality, right? Asymmetric means they don't have equality, right? So if you think about one attribute, the severity of the disease, right? High and low. This just imagine these are the two values. The severity of the disease, high and low, right? So if the severity of the disease high means that is more impact, more negative impact to the patient, right? But if you think about the severity of the disease is low means he's close to healthy, right? So that is a low impact to the low negative impact to the patient, right? So if we have a equal weights for those values, then we can say that's a symmetric. If they don't have a equal weights, we can say that's a asymmetric, right? In binary attributes, right? So the gender, the true or false, the Boolean values, right? Okay, yeah. Okay, you have if condition, right? You are checking x percentage sign 2 is equal to 0, right? So you are creating a variable x, right? For the variable x, you are get the user input, right? The user input. So you are getting the user input for x, right? So we have a variable x. You are creating a variable integer x, right? For the x variable, you are getting the user input from the users. Maybe you are using, if it is you are using a scanner class and you are getting the user input, right? Then you are checking a condition, right? X percentage sign divided by 2 is equal to 0 means you need to print. What is this? Tell me. So I think you already know, right? So what is this code? It's related to else.
If condition.
No, I'm asking it is related to which code?
Even odd
So
number.
Odd even.
yeah, odd
Fine.
even, right? Yeah. So this is even number. Remainder is 0. This is odd number, right? So here, whatever the value user pass, they have only two attributes, right? What are they? Maybe 0 or 1, right? So this is the output of this function. Maybe we can think about that is a binary attribute, right? So don't think my question paper is coming the same way. I'm giving you a table and ask. Maybe this type of question is also possible, right? So I'm asking you a code snippet, and so for that one you need to code reading, right? So you need to read the code, right? That's why we are learning, right? So if you are in the university, whatever the things you are learning, definitely you need to apply upcoming semesters, right? But there is a fall news we are sharing. You don't need to memorize the things in the upcoming semesters, right? Definitely you need from the beginning to the end of your degree program all the things you need, the basics for even if you go forward, right? So if I ask you what is the type of attribute for the print value, or maybe I'm here, I'm hold these values in a particular table. So all the possible values are even and odd. These are the two possible values, right? So this is we can call binary attribute, right? Okay, the next thing, ordinal attribute, right? So ordinal attribute means there is an attribute, they have some possible values. These possible values have meaningful order. So the previous one we are discussed, they don't have meaningful order, then we can call as a nominal attribute. If you have a meaningful order, then we can call that is an ordinal attribute, right? So if you look at anywhere in upcoming subjects, upcoming lectures, ordinal attribute. So first thing you need to understand, if it is an ordinal attribute, they have meaningful order, right? They have meaningful order between the attribute values. That is the thing you need to understand from this. Ordinal attribute means they have meaningful order, right? So the previous example, the Likert scale, right? Your exam grades. So they have meaningful order, right? Maybe just think about you visit a Pizza Hut or you visit a restaurant, right? They have different packages, small, medium, large. Maybe if you purchase some dresses, they have sizes, small, large, XL, likewise, right? So these type of values, they have meaningful order. Like the meaningful order means depending on the value, you can find out something. You have meaningful things about the attribute value. So that is we can call ordinal attributes, right? If you don't have a meaningful order, then we can call as a nominal attribute. If you have a meaningful order, then we can call as a ordinal attribute, right? So the third one, we already discussed a binary attribute. The last one, that is a numeric attribute, right? The fourth one, numeric attribute. So the numeric, the number attribute, right? So the numeric attributes, the number values, the numeric values, the quantitative values we can call that is a numeric attribute, right? So the numeric attributes we are getting from measure or the counting, right? So these are the ways we can find out the numeric attribute. Just we are measure by using an equipment, right? So you have a weight measure scale, right? By using the weight measure scale, you have measure the weights, right? That is a numeric attribute, right? Let's say you find out your height by using a measure tape. So, right. Also, I'm find out the number of people attend the class lectures today, right? That is a numeric attribute, right? Your attendance, let's say 35 or 42. That is a numeric value. That is, we are counting the values, right? So for if you have a numeric attributes, maybe we are getting by using measured by using a device, or we are find something based on the counting, right? So that is the next thing we are planning to discuss: continuous and discrete attribute, right? The continuous attribute and discrete attribute, in the sense, they are based on whether we are getting from measure or whether we are getting from count, right? If you are counting something, that is an integer value, right? If you are measure something, they have real numbers, right? Maybe the decimal value is also possible. If it is a counting, that's a whole numbers, right? There is, let's say, if I count your attendance, I will tell the whole numbers, right? I can say 25.75 students are attend the class. That is not the way, right? That's a integer values for the counting, right? If I counting some attributes, and if I find the value, that is a integer values. Let's say if I measure by using a weight scale or the measure tape, maybe there are possibilities it comes decimal values as well, right? So these type of things happen in the measured values, right? So the measured values we are discussing in the next slide. Measurable values we can call as a continuous attribute. Countable values we can call as a discrete attribute, right? That's the next type we are discussed, right? Continuous and discrete. So these are defined based on the countability and measurability. So if you have a numeric attribute, they have interval scale, right? Interval scale in the sense, right? Let's say you have 0 to 25 age, 26 to 50, 50 above 50, right? 50 plus, right? So this is an example for interval scale, right? Ratio scale means 1 is to 2, likewise, 5 is to 10 is to 20. So the ratio 5 divided by 10, the ratio between the son and father, likewise, the ratio, right? See, these are the possible values for numeric attributes, right? So the interval, the temperature, right? 0 to 33 Celsius, 34 to, these are the interval, right? There is a range interval, right? So you don't think more that, right? So if it is a numeric attribute, that is a numbered value, right? Maybe we have to extract the numeric values by counting and measuring, right? Countable values we can call as a discrete attribute. Measurable values we can call as a continuous attribute. That's the next thing. Yeah, before move to that one. Okay, maybe just look at the table right now. If whatever the table, if you are find, or if you look at a table with some values, you need to think whether which type of attribute this one. So tell me, what is the type of attribute for age? Age is a numeric attribute, right? You don't need to worry about the duration, also a numeric attribute, right? So the next two things, marital status, right? So now look at here, you need to check. So if it is a categorical data, so this is a numerical data. This we can call as a categorical data, different categories of, right? Different categorical data. If you have a categorical data, you need to, what are the different categorical data types we have? Nominal is a categorical data, right? Ordinal is a categorical data. Binary is a categorical data, right? Nominal means there is no meaningful order, right? There is no meaningful order. If you have a meaningful order, then we can say as a ordinal. Binary, only two values, 0, 1, or yes, no, likewise, right? So now if you look at the marital status, if I ask you what is the type of attribute for this one, first you need to check what are the possible values for these, right? So here the possible values are married, single, only two possible values, right? So tell me, what is this?
Binary.
What type of attribute?
Binary.
Binary.
Yeah, binary. Maybe sometimes for one attribute, they are satisfied with more number of types, right? That's also possible, right? So here we have only two values, right? So this attribute is a binary attribute, right? Also, we don't have any meaningful order, married and single, right? So that is also considered as a nominal attribute. Now, if you look at the education, right, what are the possible values? Primary is there, secondary is there, tertiary is there, right? It means more than two values, right? Directly then omit binary, right? Now there are two
Nominal.
possibilities, ordinary or
Ordinal.
nominal. Here, they have meaningful order based on your education, primary education or secondary education or tertiary education. Depending on that, you have some value in the society or whatever. You have some values depending on your educational qualification, right? So here we can say this education is an ordinal attribute. Right. Okay, just look at this table. Okay, if you look at the sex, so they have male and female, right? So that is a binary attribute. The first one is a binary attribute. What about the age? Age is a numeric
Numeric
attribute, right?
attribute.
Sorry. So the weight is a numeric attribute, right? So even you can say the age, maybe we are counting the ages, right? Because the whole number, this is a counting, age counting. Here we are measuring something, right? So we will discuss the next thing, whether what is the discrete attribute, what is continuous attribute. So then you can realize whether within the numeric attribute, whether it's a uh, discrete value, discrete type attribute, or continuous value, continuous attribute type, right? For all the numeric type, we can say whether it's a discrete or continuous, depending on how they are extract the values, right? Height also numeric, right? If you think about the smoking behavior of a customer or the patient, they have yes and no's, right? So this is a binary attribute, right? Yeah, the religion is first you need to check the Christians,
Not
right? Hindus, Buddhists, right? More values. But if you think about the religion, we can say one religion is good, one religion is bad, right? That is a common behavior, right? So we can say that is a or sorry, that is a nominal attribute,
Nominal.
nominal attribute, right? So if it's an ordinal, they have meaningful order. So for between the races or religion, we cannot say which one, this one is good, this one is bad, right? So that is a nominal attribute. Now we will look at what is the difference between continuous attribute and discrete attribute. There are two types, discrete and continuous attribute. Now we will look at what are the difference between discrete and continuous attributes, right? Okay, you can take a 5 minutes break and come back quickly. Okay, shall we start? Any questions? If you have any questions, you can ask. Shall we start?
Yeah, sir.
Yeah, okay, thank you. Okay, now next we will move what is discrete attribute and continuous attribute, right? I already give a brief about what is discrete and what is continuous attribute, right? So the discrete attribute in the sense they have countable values, right? If it is a continuous attribute means they are measurable values, right? So the meaning of discrete attribute means they have clear space between the values, right? So clear space in the sense, if it is a 1, that's a whole number, right? There is no 1.1, no 1.001. Likewise, there is no any confusion. If it is a 1 means that is a whole number. There is a clear space between the values, right? Let's say if it is a 1 and 2, there is nothing between these two, right? This is a whole number. This is another whole number. Between these two, there is nothing, 1 and 2, right? So similarly, 10. So exactly, they clearly mention what is the value is, clear space, right? But not the case in the continuous data, right? Continuous means that is a continuous sequential series, right? Let's say continuous data means, let's say cells, let's say if you have a continuous data, the measurements, right? So if you measure something by using the centimeter scales, you are getting something, right? The same thing, if you measure between the millimeter scale, you are getting something, right? The continuous means the sequential data, right? They don't have exact values. They have some continuity, right? Depending on the device or depending on the equipment you are using to measure, they are varying, right? The continuum values, right? So if it is a discrete data, we can count the values, right? The data tuples, data values are we are count. Yes, we can count for the discrete value, but not the case in continuous. Generally, not the case. We are not count in continuous, right? If you think about the measurable things, right? Here, discrete we are not measure, but continuous we are measure the values, right? If you look at the values for the discrete data, they have finite number of possible values, right? They have finite number, right? They have fixed number of values, finite number of values. But if it is a continuous data, they have infinite number of possible values, right? So we can plot with the bar chart for the discrete values. We can plot with the histogram for the continuous values, right? So the histogram we are using for the continuous attribute, right? So there is nothing, just you can remember, if it's a discrete attribute, we are get the discrete values by counting the values. If it is a measurable values, we can say that is a continuous attribute. If you measure something and if you do the readings or if you find out the values, that is we can call continuous attribute. If you are counting and if you plot or your record, that is we can call discrete attribute. I think in the first practical session you discussed the the second practical session you discuss some basic statistical operation, right? So mean, median, mode together we can say central tendency, right? In mathematics statistical term, if it is a central tendency means they are include three items: mean, median, and mode, right? So just to complete this subject, until you finish the subject, you need to know what do you mean by the mean value. Mean means the average, right? So you need to get the sum of all the values divided by total number of instances, that is we can call as a mean value, right? If it is a median value means what? Median. So maybe you
Center.
know Q2, the middle value, right? Let's say you have, let's say, now just think about, yeah, just imagine recently you got the results for one subject, right? So on that subject altogether, we have 100 student marks, right? 100 student marks. Just imagine that is a marks, right? Not the grade. You are getting a marks for the 100 students, right? So the median value means the middle value of these all 100 marks. The important thing to find out the median, right? To find out the median, first of all, you need to write in the ascending order. So first of all, right, you don't find out the middle value, whatever they are giving, right? So the first thing you need to order the values in the ascending order. After that, you can find out the middle value. That is important, right? I will explain with an example, right? Let's say if you have 100 attributes, right? So you need to find out 15th attribute plus 51st attribute, sorry, 15th value. So first of all, you need to order the values, right? So then you can find out the value of the 15th data, 15th record. Here the 15th record, here 51st record, here 100 is there, the first record, 1, 2, 3, it goes 50, 51 until 100, right? So you need to take the value of the 15th record and you take the value of the 51st record. Then you can get the sum divided by 2. That is the Q2 median. That is the middle value, right? The median means that is the middle value, right? Mod value means, I already mentioned, right? The highest number of occurrences, which value occurred highest number of times, that we can call as a mod value, right? So what do you mean by range? Okay, if you have a marks means, what in this 100 marks, tell me what is the range?
1
What
to
is the
100.
range here? No, this is not marks, right? So this is a number, right? Student numbers, right? This is not marks. Just imagine this is just 100 tuples. For mention that 100 tuple I told you, right? So here marks are, just imagine 25, 37, 85. I put 85, I can't do all the things, right? So here 38, 38, 41, 50, 52, 53, 55, 55, 75, 78, 89. Okay, now tell me, what is the range? Range means what?
Smallest number to largest number.
Minimum value to maximum value, right? The smallest value and largest value. So the range is here 25 to 89. So that is the range, right? So now tell me quartiles. Quartiles means this Q1, Q2, Q3 we can call quartiles, right? Q1 means 1/4 of the value, right? If you divide the entire 100 tuples, 25th marks, let's say this is the 25th marks, that is the Q1, right? So the Q2 means the 51 plus here, if it's an even number, so you are getting the sum of 50 and 51 divided by 2. If you have odd numbers, odd number of records, let's say you have 101 records. Let's say if you have a 99 record, 99 student marks, then to find out the Q2, 99 plus 1 divided by 2, the 15th data, 15th value we are considered as a 15th value we are considered as a Q2, the middle value. Q3 means 4 out of third. The third quarter we can say the third quarter, the 75th value we can say that is the Q3, right? So the important thing, interquartile range, IQR, interquartile range. To find out the interquartile range, you need to find out the Q3 minus Q1. So you need to get the Q3 value. Let's say Q3 is 75. Just imagine Q3 is 75, right? Just imagine Q3 is 75 minus Q1 is 38. So the interquartile range is what? 30. 32, right? Sorry, 37. So interquartile range is 37, right? So why we need this interquartile range? While you are dealing with data set, we have outliers, right? We have something called outliers, right? To remove these outliers, we need this interquartile range, right? So how we can find out the outliers, right? Yeah, I will write. There is an equation, mathematical equation. Let's say, just imagine you have the 100 or 1,000 records, right? 1,000 marks, right? From these marks, you need to find out is there any outlier marks or outlier values? So to find out these outlier values, first of all, you need to find out Q1, Q2, Q3. Also, you need to find out the interquartile range, right? Then from the Q1 minus 1.5 multiple by interquartile range, this is the minimum value. If any values below this one, we can say that is the outlier. So below this value, we can say below this value means Q1 minus 1.5 into interquartile range. Yeah, just a minute, I will define that. No need to remember, right? Just for the explanation, I am telling you. Yeah. Yeah, that's one. Yeah, that's correct. Q1 minus 1.5 into interquartile range. The equation. Okay. Okay. Yeah. So yeah, we know what is Q1, Q2, Q3. Also, interquartile range is equal to Q3 minus Q1. So you need to remember these things, right? So we are discussing about outliers. So to find out the outliers, right? Q1 minus 1.5 into Q1 minus 1.5 into interquartile range. If there are any values below this, below means is there any values below these, we can say that is the outlier. Similarly to Q3 plus 1.5 into interquartile range. So is there any values above these? Also we can call any values above these, we can call that is also outliers, right? So this is the equation we will find out the outliers, right? If you have a set of values from, let's say, you have a set of numbers or set of salaries or whatever the things. So to find out the outliers, first thing you need to find out Q1, Q2, Q3, right? Then you can find out Q3 minus Q1 is your interquartile range, right? Then already you know what is the Q1 value. From the Q1 value, minus 1.5 into interquartile range, that is we can call the lower boundary of your outlier, right? The upper boundary of your outliers, cube 3 plus 1.5 into interquartile range, right? So between these values, that is not an outlier, right? If you have anything above these two boundaries or below this lower boundary, above this upper boundary, we can say that is the outlier. So by using this equation, you need to remove the outlier values, right? So yeah, that's all about the basic statistical operations, right? So just you need to revise. If you don't remember, just revise the things, right? What do you mean by mean, median, range, quartiles, and interquartile range? Because we need this interquartile range for calculation of outlier values, right? So this is the equation Q1 minus 1.5 multiple by interquartile range to Q3 plus 1.5 into interquartile range, right? Maybe in the practical session, we will look at if you have a data set, how you can find out, right? So we have some plottings, right? So based on the plotting, we can find out the outlier values, right? Yeah. If you need, I will share. video, right, regarding these outliers. I don't know whether you already shared. Okay, no need that video, right? Yeah, that's all about the mathematical operation. Now we will move for the data visualization part. Right, that is very, very important thing. Even in the outlier detection, we can visualize, right? We can plot based on these equation, Q1 minus 1.5 into interquartile range to Q3 plus 1.5 into interquartile range. We can plot the graph, right? If there are any values, data points above the Q3 plus 1.5 into interquartile range or below Q1 minus 1.5 into interquartile range, we can say these are the outliers values, right? So if you plot these in a histogram, then you can easily find out whether it's a outlier or not, right? That is one way we can find out the outlier. So maybe we can plot the graph, plot the data set. Based on the data set also, we will find out some outlier values, right? So the objective to data visualization, you can clearly understand about the data, right? The compare with the theoretical representation. If I explain anything based on the graphical representation, they have more understanding. That is a scientifically proved, right? Rather than if I explain something with the paragraphs or some theoretical representation, if I plot or if I visually, graphically represent something, graphically present something, you can easily understand. Yeah, our brain have more capability to capture those things, right? So we have different visualization techniques, right? Maybe if you are doing research, here we are discuss very basics, right? Maybe if you are doing your final year research, you are familiar with all the data visualization different techniques. You need different visualization techniques uh, to disclose your results or to disclose your findings to the research or to do a presentation. Definitely, you need to visualize the data, right? Pixel oriented techniques, geometric projections, right? The 2D, 3D diagrams, right? With X, Y, Z axis, icon based techniques, hierarchical techniques. These are for mostly using techniques in data science to visualize or visually represent their data, right? So I think you have a subject called artificial neural net. Sorry, the yeah, AI, right? You have a subject called AI, right? Artificial intelligence for this semester.
Yes.
You have a subject. Yeah, okay. Then you are learn something called gradient descent, right? For a global optimum, right? Local optimum. There are so many things you are discussing, right? The yeah, global optimum value, local optimum, right? Maybe if you are following some course module in the course area related to machine learning, you are learning these things, right? So to find out these global optimums or local optimums, you need to use these, yeah, hierarchical techniques, right? So hierarchical technique means nothing, right? You are drawing the plot diagram. So it's so this one, right? You have some graphs this way. So this point we can say global optimum, right? This point we can say local optimums. So there are different local optimums, but only one we have global optimum, right? So if you are train some models, that's a knowledge I'm selling here, right? If I train some models, definitely we need to find this global optimum, right? That is the best point to develop our model, right? If you stop with the local optimum, your model is underfitting or overfitting problem will come for your model, right? So that's why you don't think about these things, right? To do those things, you need these type of plottings, data visualization techniques, right? Yeah, just we will look at one by one. Pixel oriented techniques. Tell me the depending on the name, you can understand what is these visualization technique. Pixel oriented. I think we can represent the images by pixels, right? Pixel values. I don't need to explain more about these pixels, right? If you have an image, right, 256 pixels into 256 pixels means what? Tell me, you have an image, 256 into 256 pixels. What do you mean by this? Hmm? To know these things, you need to learn computer vision or image processing, right? That's why I ask you to learn these things, right? If you have a vast knowledge on that, you don't need to worry about your career, right? There are so many job opportunities for these type of jobs, for the data scientist or the computer vision people, right? So tell me, what do you mean by 256 pixels into 256 pixels? These are some basics, maybe it can be helpful for your career. That's why I'm explaining these things, right? Even you don't need to consider for this subject for about pixels, right? But you need those things, these basics, right? I think you have a subject called that image processing or something, right? That in the first year or something, you have a subject, right? I think, right? The graphic designing and other things, right? Am I correct? Am I correct? You have a subject, right? Hello. Do you have a subject called, I don't remember. I think you know the basics of images, right? Am I correct? Or you don't need, otherwise it's a waste of time. That's why I'm asking you. Do you know the basics of images? Tell me, do you know the basics of images? Tell me. Hello. Am I audible?
Yes, sir.
Okay. Then if you know, tell me. Otherwise, I don't think, right? Justify. If you don't know, I will tell. Otherwise, just I can revise. Don't fear, right? I don't ask any questions, right? If you don't know something, then you can tell me, right? Otherwise, I think you know those things, right? Sorry. So yeah, I think I think you know the basics of image, right? If you have an image means what? Tell me. So just imagine you have an image called 256 into 256 pixels. What do you mean by this? Anyone know? Any volunteer?
Image, sir.
Sorry?
Size of the image.
I didn't understand. Can you tell me again?
Height and
Size.
width of
Voices.
the image.
Yeah, dimensions, right? So dimensions means what? I think you know, right? So yeah, very good. Dimensions, yeah. Height and width. It means not actually height and width, right? Maybe you're not clearly understand, right? So the dimension is okay, right? Dimensions means what? I already told you the term dimensions. Tell me. You're close to the answer. Previous slides I explained different names for the variable, right? So dimension means that's a variable, right? So here, if you have an image 256 into 256 pixels means, right? Here in this image, you have 256 into 256. That's a huge big value, right? Get the multiplication of 256 multiplied by 256, right? You are getting a big number, right? Give me 1 minute. Okay, we will continue. Right. So 256 into 256 means that is a dimension. It's correct, right? So dimension means what? That is attribute, right? So if you look at a 256 into 256 pixel image means here, just imagine you can get the value of 256 into 256, right? That's a big number, right? Maybe 10, yeah, 256 into 256. Yeah, 65,650, 636, right? So here in this image, 65,000, right? 256 divided by 2. Here, this number of 65,536 attributes are there, right? In this image, these number of attributes, values are there, right? Did you get my point?
Yes.
Yeah, that is a color image. I will explain those things. Yeah. Right. So it means in this image, this number of attributes are there, right? So so now you know here 65,636 attributes are there, right? So you think here, just look at here in this image, right? 65,536 attributes are there. So if you have attribute 1, 2, attribute 2, attribute 3, for each attribute you need a value, right? So if you have an image, those values are, for these values, the possible values are 0 to 255, right? These are the basics of image, right? So maybe if you need, you can search in the internet and look at those things, right? So the possible value for this, each attribute in the image, 0 to 255, right? This is the value. Maybe between these 0 to 255, you can put some values, right? 0 is a black, 255 is a the white, right? Okay, here, right? For here altogether 65,636 image attributes are there. Each attribute, the values between 0 to 255, right? So if it is this is for grayscale image, right? The black and white image, this is the theory, right? This is for grayscale image. For the grayscale image, black and white image, we have 0 to 255, the value, right? I don't remember exactly. 0 means black, 1 means white, or 0 means white, 1 means black, right? That is a difference. So black 0, if it's a black 0, 1 black 0, 255 is a white. If it is a 1 is a 0 is a black, 1 is a 255. It means if you are putting a 0 value here, that is a black, right? If it is a 255 means that is a white color, right? So this is for grayscale image, right? If you have a color image, you have 3 channels, right? If it's a color image, you have, if you have a color image, you have 3 channels, right? RGB, red, green, and blue, right? These are the 3 channels, right? Here for each channel, you have again 0 to 255, 0 to 255, 0 to 255, right? So these are the color image, right? So just think about, you have an image, let's say you have an image 5 megapixels, right? So if you have a 5 MB, so 5 megabytes, right? So if you have a image 5 megapixels means here 5 into mega means 10 to the power 6 number of attributes, right? So that's a basic I'm telling here, right? So the fix, if you need to learn more, just you can revise the image basics, right? So if you are planning to do a research related to this area, definitely you need these knowledges, right? What is the channels? So maybe we cannot directly use these numbers, right? So we apply some normalization technique. There are so many things I can't explain here, right? So if you have a pixel oriented technique means the same concept, right? We are using the pixels. Just look at here. This is a pixel-oriented graph, right? So if it is a white, they have some values, maybe 0. Here, this is a black. So it means 255, or it's up to here. I'm telling for that is the basic for image, right? So pixels means for each pixels values, they are assigning the data points, right? So this is each pixel have specific value. Based on this, if you plot the data points, that is we can call pixel oriented techniques, right? So these are very important, interesting and important topics, right? Just go through the image processing on computer vision, right? The fully mathematical things. You need to know the knowledge of matrix, right? I think you learn those things or not. Matrix, there is a topic called matrix in mathematics, right? If you know the knowledge of matrix, you can easily pre-process the images, right? Pre-process or image processing means just imagine you have a blurred image, right? So now you need to increase the contrast, or you need to do, there are so many modification or editing with that image. You need to, if you know the expert on this computer vision and image processing, you can do whatever the things with your images, right? So those things are important if you are doing a research related to this area, right? That's why it's explained here, right? So the pixel oriented means depending on the pixel values, you are plotting your data, right? So each pixel value have specific numbers. Okay. This is an example of pixel oriented techniques for plot the data, right? Another topic, another type, geometric projection. Geometric projection, right? So the geometric projection in the sense, so the geometric product. அங்கே போங்கம்மா முடிய போகுது. ஆமா இவன் போட்டுதான் அங்க போட்டு தெரியும். Sorry. Okay, geometric projection techniques means that is related to axis, right? The y-axis and x-axis. This is already, you know, right? Two-dimensional, 2D models, right? So 2D models we can use by using this x-axis and y-axis, right? So sometimes what will happen, we have n dimension, right? If you have 3 variables, right? Let's say you have an image data set. Let's just think about this is age. This is an experience, number of years experience. Years of experience. I think it's not possible for years of experience. I just imagine this is their salaries in dollars, $1,000. Okay, just imagine. Okay, this is salary attribute, right? So now we need to plot the graph, or we need to cluster, or whatever the things, right? So at that time we need to plot variables, right? If you have only 2 variables, that is a two-dimensional graph. Sometimes we have another attribute called education and educational qualification or something, right? So depending on this geometric coordinates and geometric things, if you plot your data, that is also one way you can display your outcomes, right? Or if you are doing a data science related research, definitely you need to plot these type of things. Or maybe you are using the pixel oriented visualization techniques, or we are using geometric projection techniques. The third one, the icon based, right? So if you look at these plus icon, they are indicating some meanings, right? Sometimes you are using that circles, right? Sometimes using that bullets. Likewise, you are using different icons to plot the data, right? That is one technique. The fourth one, hierarchical techniques, right? That is a 3D modeling, 3D that layers. You are plotting based on the 3D layers, and you can visualize the your outcomes, or you can visualize your pre-processed data for some purposes, right? So these are the 4 commonly used techniques for visualizing techniques your data, right? Yeah, that's all about the data, the topic today what I covered, right? If you have any questions, you can ask. Next class we are planning for data pre-processing, right? That is very, very important for you guys, right? So before you start any data mining task, definitely you need to clean the data, right? So here we are going to discuss about the pre-processing technique.